Hi, my name is Emily Weber. I'm a machine learning specialist solutions architect at Amazon Web Services, and today we're going to learn about Hugging Face on SageMaker. This is your deep dive. So we have 3 videos for you to really understand Hugging Face on SageMaker. This first one is your introduction. The second one is a deep dive on training, and the third one is a deep dive on deploy. So let's first look at the introduction. And so, before we want to talk about Hugging Face, we actually want to understand the concept of a transformer. And no, I am not talking about cars that turn into robots that save the human race. I am actually talking about a new type of NLP model. So if you have been following the machine learning general press for the last 4 or 5 years since 2017, you will be familiar with this concept. If not, welcome to the world of transformers. So transformers have been demonstrating state-of-the-art and near human-level performance, in some cases actually exceeding human-level performance in natural language processing use cases across text classification, token classification, text generation, question answering, and those translate into any type of NLP use case. So if you are using search at your company, if you're doing question answering, if you have chatbots, if you are working with documentation, if you deal with text in some capacity, odds are you can improve your business efficiency using transformers. Now, transformers are great for both large unsupervised data sets and for smaller domain-specific data sets. They use this concept of pre-training to gain intelligence on really, really large data sets. So all of Wikipedia, all of Common Crawl, many different book data sets, you can use those pre-trained models and then fine-tune them on your data. So on a much smaller data set and on something that's more specific to your business and to your customers. Transformers themselves are highly scalable and parallelizable, so they take advantage of all the GPUs, all the nodes in your cluster in a way that recurrent neural networks and other sequence-based approaches really haven't been able to. They understand both the word and its context using this concept called self-attention. I'm not going to go into detail here, but definitely read more about it if you're interested. Both bidirectional, so forwards and backwards, in addition to just strictly left or right for generating. And generally speaking, again, transformers can raise the level of intelligence on almost all of your NLP models. So for any NLP model that you use for customer support, for, again, document search, for document retrieval, odds are you can use a base transformer model to just raise the level of intelligence. And first off, there's actually a book. So the Hugging Face team just published a book on this. So it came out in February, March of 2022. I have been absolutely eating this up. It's been my candy for the last couple weeks. And so we're going to be looking at some of the topics that they mentioned here today. So if you're asking yourself, well, Emily, what is Hugging Face? What exactly is going on? So the net here is that NLP is really exciting, right? In the last few years, we've seen state-of-the-art performance in computer vision with object detection, with image classification, ResNet, and in the 2017-2018 timeframe, we saw that start to switch, where many of the insights that we learned in computer vision were applied to natural language processing, but in particular, there's this new model called the transformer. And so Hugging Face is an SDK and a suite of tens of thousands of pre-trained NLP models, tokenizers, datasets, example notebooks, and scripts that wrap state-of-the-art NLP models and make them really easy to use. So in just a few lines of code, we're going to get absolute state-of-the-art performance across text classification, across named entity recognition, question answering, text generation, translation, training from scratch, fine-tuning, all sorts of things. Hugging Face also produces code generation, so you can go onto their site, and we're going to look at this and pick the model that you're interested in, determine the downstream task that you want for it, whether it's, again, text classification, named entity recognition, etc., and then you can actually generate the config for that. We're going to generate the code configuration to just run that on SageMaker. And also, Hugging Face has an awesome open source community. I mean, I follow their GitHub repository. It is incredibly active. You're going to see many pushes every day. They have a really just robust open source community support. And so today we're going to learn how to use Hugging Face on SageMaker. So now that we know what Hugging Face is at a very high level, what can we do with Hugging Face on SageMaker? The answer, my friends, is a lot. We have a huge amount of features that are purpose-built for Hugging Face on SageMaker. So at the core, you're going to see two what we call deep learning containers. So they're Hugging Face deep learning containers, both for training and for inferencing. But then we're going to wrap on top of that many different features across the stack. So we can really look at them in three different ways. We have features for training, features for deployment, and then features for operationalize. And so in the training side of the house, you're going to see fine-tuning, so the ability to fine-tune those NLP models. Again, the deep learning containers, we can tune them using automatic model tuning and SignTune. We can compile them with the SageMaker training compiler. We can distribute them across multiple GPUs, multiple accelerators, multiple nodes, and then we can also train those from scratch. In the deployment, we can deploy those tens of thousands of pre-trained models directly from the Hugging Face Hub. So that's going to be one line of code where we're going to, again, point to the models that are pre-trained in the Hugging Face Hub, and then we're just going to deploy those onto SageMaker. We can also deploy fine-tuned models from the hub from S3 onto SageMaker. Again, both with PyTorch and TensorFlow. And then we get all the same features for deploying on SageMaker that we do with Hugging Face. So auto-scaling, support for serverless endpoints, asynchronous endpoints, multi-model endpoints, Inferentia, and Neo. On the operationalized side, you're going to look at SageMaker pipelines, really any third-party MLOps stack that you want to use, fully compatible with Hugging Face. We also have a new inference recommender, so you can use inference recommender to find the best instance type and then configure that instance for you. We can also detect and monitor for bias in text classification models with SageMaker Clarify. So how do we pick the right Hugging Face model? This is a very common question. The first piece of advice that I would say is try and add value to your organization as a step one, right? Figure out what areas are your organization most interested in, what data sets do you have, what problems are most relevant to you, and then try and backtrack that into a type of use case that Hugging Face supports, whether that's, again, question answering, summarization, token classification, text generation, all sorts of things. We want to ask ourselves, is my data set primarily in English? Or do I need a multilingual model? Do I need a model that has support for multiple different languages? Also, how specific is my data set? And especially, how different is it from a pre-trained model? All of these tens of thousands of models that we're looking at have been optimized for a research data set, whether that is SST2 or Squad or Common Crawl or books. And so essentially, we want to ask ourselves, again, how different is that data set from my data set? And then will the research data set performance meet my needs? So you'll find that each of these models has a benchmark performance for how well it performed on that specific data set. And so we want to ask ourselves, what would be the impact of that level of accuracy, of perplexity, of BLEU score within my use case. And then go forth and experiment. There are, again, so many different models and so many different methods. What I really like to do is time backs. I like to spend 1 week, 2 weeks exploring one of these models, exploring one of these candidate use cases, and then rinse and repeat. And then only after you've found a model or a use case that's really performing well, after that point, it's appropriate to start scaling. And we'll learn all about that in just a little bit. And so with that, let's take a look at the demo. All right, so here we are. So you see we're sitting in SageMaker Studio, and I'm in US East 1. And in particular, I have a notebook, and this notebook uses the Distilbert model. The Distilbert model is common for classification, and so we're going to build a binary classifier using this Distilbert model. And we're going to use it across 3 different phases of SageMaker. So this first phase is installing and using that model locally. where we're actually building a very small scale but still performant text classifier locally. And so we're doing that on Studio. The second phase is where we run a training job, where we're going to take a new data set. We're going to fine tune this model on that new data set using the SageMaker Training API. So we're going to have new EC2 instances within machine learning coming online. We're going to copy our data out to those instances and run a job. And then in the third stage, we're going to take our fine-tuned model and we're going to deploy that onto SageMaker for real-time hosting. So let's get started. All right, so you'll see in this first cell here, we're just installing some local scripts. So that's that SageMaker Python SDK, and then Transformers. And so remember, Transformers is the flagship Hugging Face SDK. They have, again, a really robust GitHub repository and open source context and support. And then the datasets library is another SDK that's built by Hugging Face, and it gives you access to a lot of datasets that are relevant for Hugging Face. So let's install both of those. And then in our next step here, we're going to build what's called a pipeline. So the Transformers SDK has this pipeline object as a construct, and it's really nice because it wraps all the different stages of this classification process from loading the model to performing tokenization to actually, again, getting that pre-trained model, tokenizing the incoming text, running that through the pre-trained model, generating the text, and then loading that back. And so that's why this pipeline construct is really valuable. So here, we're just going to pass in one phrase, which is sentiment analysis. And so this classifier that we're building is going to give us a binary classification on the sentiment of the text that's passed in here. And so when we call this classifier on this new piece of text, it's going to come back with a score, right? And so in this case, it comes back with a positive score. So that comes directly through, again, this pipeline object. So now in the second step, we're going to deconstruct this a little bit further. We're going to point to not just a generic type of problem, which was the sentiment classification, but we're going to point to a specific model. So this model is, again, one of the more than 30,000 transformers that are pre-trained on the Hugging Face Hub, as it's called. And so I'm pointing to the maker of that model, which is NLP Town, and then the model itself. So we've got a BERT base, multilingual, so support for multiple languages, uncased, and then sentiment. And we're going to use this first object here, auto model for sequence classification dot from pre-trained. So we're going to load in the name of this model. Now it's nice because if you have your own model, you can pass that here as well. We'll just say dot from pre-trained and then actually just pass in the local path of that model. And so, yeah, so that's going to get loaded in here. And so that's our model. The next step is our tokenizer. So if you've worked with NLP, you know that really the heart of transforming text into something that a computer can read is really about tokenization, is where we're, again, taking the strings, and then which is the raw text, and then breaking that string up in a way that's appropriate for the model. Now, the beauty of the Hugging Face SDK is that they have tokenizers for each model. So whether you're looking at GPT-2 or Roberta or Distilabert or Big Bird or DBERTA or any of those models, they actually have tokenizers that are loaded for these, and those are all just available on the hub. So here I'm going to pass in the name, again, of my model, and I'm going to get a tokenizer. And now I'm going to use that same pipeline construct, except now I'm passing in a specific model and a specific tokenizer. So I'm just being a little bit more fine-grained there. And then I'm going to run the classifier again, especially the large-scale distributed training, which is definitely fun. And so we're gonna run that classifier here, and we get the same score. Now we're going to take this one step further. We're going to fine-tune this model. Now, fine-tuning is incredibly valuable. Number one, because you need less data. Fine-tuning means you're pointing to a pre-trained model, And it could be a really large model. It could be GPT-2, it could be GPT-3, it could be Big Bird, it could be, really any of the state-of-the-art NLP models. And we're going to piggyback off of that model and that team's work, and then add a few more layers onto it, or more specifically set some of the last layers to trainable. But we're using, again, the Hugging Face framework for it, and they abstract away a lot of that lower level work. But we're going to bring our own data, and we're going to make that model more specific to our data set. So that's really what this next step is. So we're importing that SageMaker.HuggingFace framework right here. And then this is just setting our normal SageMaker credentials, right? So we've got our session, our bucket, our role. Life is good. We're going to load in that tokenizer. So this case, the DistillABERT base uncased. So similar to the previous one, just not strictly multilingual. SST, and then we're going to load the data set, which happens here. But in this case, actually, for the demo, we're going to be pointing to data that's already been hosted in S3. So we've got some SageMaker sample files sitting in a readable S3 bucket, and so we're going to load those here, and then make sure that we have them accessible, and then we're going to drop those into our S3 bucket in short order. All right, so we've got the tokenizer downloaded, and then the train and test sets. So we're all set. There we go, and then we'll upload those to S3. Now, we're gonna run a SageMaker job. So remember that SageMaker training job using the Hugging Face deep learning containers. So remember, we have pre-built Hugging Face containers in the SageMaker family, both for training and for hosting and for all the rest of the capabilities that we were just looking at. So we're going to initialize, again, that Hugging Face construct right here, and then we'll define the hyperparameters that we want for this job. When you are just starting with a model, it is strongly recommended to set epochs to a small number, because epochs is essentially a full pass through your data set. And so if you set epochs to a high number, it just means your job is going to be training for a long time. And unless you have a model that's ready to go, you may not want that. So it's better to start with a smaller epoch number. We're also going to pass in something called train batch size. So that's literally the number of records in your data set the script is going to be picking up to pass through your network per batch. So train batch size 32. And then our model name. So here's our estimator. So we have that Hugging Face construct, and the entry point is a local Python script. Now that local Python script, happy to tell you, is optional. So in the training deep dive video, we're going to look at more specifically passing in a GitHub config. So you can actually just run the Hugging Face code that's sitting on GitHub. You can run that directly from your SageMaker estimator. But here we've got a local train.py. Let's see if we can open that up here. So that's out here in my scripts folder. There we go, train.py. So let's look at this briefly. So remember, from transformers, that's that Hugging Face SDK. We're going to import from there. These should all look pretty familiar. So that auto model trainer API is the Hugging Face base trainer API, super useful. Training arguments, and that tokenizer. And so if name equals main, remember that's how we start our scripts, generally speaking, but especially we do them a lot in SageMaker. And then we'll start with quite a few arg parsers. So we're going to add in the epochs, train batch size, etc. Load in our data sets from disk, turn on the logger, and then what do you know? It's exactly the same scripts we saw from earlier. Remember, so auto model for sequence classification, and then that auto tokenizer. The difference is that now we're passing it into a script, and then we're going to run it on the SageMaker training backend. So we're defining our training arguments. We're going to pass that into the trainer, call trainer.fit, trainer.train. Then we'll run an eval, and then save the model out to S3. So that's our training file. And let's look at that in action. So we're going to say estimator.fit, right? And we're going to point to our training and test data sets, which are landed in S3. And so this happens exactly as you think. We have a P3.2XL, so that's going to be one NVIDIA V100 that's coming online in the SageMaker training instance. And so we're printing out the hyperparameters and the inputs and outputs, environment variables, and then the play-by-play. So just loading in the model itself here, counting the parameters, and then all sorts of downloading, and then lots of tokens. And so I'm just gonna close this here because that's a bit of an eyesore. But the net is we train our model, the model trains. And then once it's trained, we're gonna do another complex maneuver. I say with tongue-in-cheek, this is not a complex maneuver. We're going to say estimator.fit, and again, just using that estimator that we did in order to run the job, we're going to use the same estimator here and say .deploy. So we're going to deploy that endpoint. In this case, we're deploying onto one m5.xlarge, so one extra large general purpose compute instance. And then, so that's our predictor, and we'll pass in our inputs, and then we'll get the score. So, so in this demo, we fine-tuned a BERT model. We trained it on SageMaker, and we hosted it on SageMaker. And we're gonna just briefly take a look at some of those objects in the console, if that's your preference. So again, here I'm in the SageMaker AWS console. This is the dark mode, you'll see. And essentially, I'm gonna look at this training job. And you'll see I've got my P32XL. This was one machine I was running on. My data set is loaded in S3 here. And my test data set is also loaded there. And I'll be able to look at some very brief, remember this was one epoch, so definitely a short period. And then my model artifact was hosted again in S3. So after the job completed, I was able to look at the model output in S3. And then when we deployed it to the endpoint, again, we actually created this new SageMaker instance in the back end, which is hosting that pre-trained model. And so here's my endpoints. I have monitoring enabled on my endpoints, so I can look at the utilization across a couple different settings there. I can specify the traffic, and I can double click on the model that's hosted there, which is this model specifically, using this image, pointing to my model data in S3, and that's what I got. So I hope you enjoyed the demo, and so now we'll close it out with some pro tips. So number one, if you're unsure which model to use and how to utilize that model, I would say try and have a preference for fine-tuning. Actually, when you fine-tune a model, you really have a chance to just make it more specific to your data. That model is going to know more about your data. It's going to be more in the style of the text that you prefer. It's going to be more suited to your use cases. So I would say try and have a preference for fine-tuning your model. Another preference you should try and have is just use the Hugging Face scripts. Like they have, again, a huge amount of examples. They have code samples available. They have notebooks available. They have lots of scripts. Their scripts are lovely. They're updated regularly. They work excellently. Really try and use those directly. And in the training video coming up, we're going to double click on that specifically and just really unpack what's going on. And then the last pro tip I would have is just plan for bias, actually. NLP models, very well documented, they inherit the bias that sits in their data sets. So it's common to see bias around especially social characteristics with different individuals, ways of describing those individuals. Models will put them into different profiles. And so when you are designing your model, anticipate some level of bias. And again, SageMaker Clarify has some bias detection capabilities, especially for text classification. And then you can also monitor those models for bias as well using SageMaker. And with that, thank you very much. So there's also a 30-day free trial for O'Reilly. So that tiny URL, you can go ahead and click on that if you prefer, and that'll give you 30 days of reading O'Reilly books. And then you too can get your very own O'Reilly copy and join me in reading. So thanks.